Hello, this is Dr. Mears, and today we're going to be describing graphs of logarithmic functions. Our example, the function f of x equals log base 10 of x minus 2 plus 1 is given. Describe the transformations necessary to transform the graph of g of x equals log base 10 of x onto f. Let's break this down a little bit. First, let's go to the parent function here, log base 10 of x. Let's graph that one first. Let's sketch it actually. So this is x and this is y. We need 1, 2, 3, and let's just do that on all of our axes. Take a second to do that. There we go. Okay, now get out your graphical display calculator. Now on the calculator, you're going to notice that we have our log button here. Notice it doesn't have a little 10. It does have a 10 raised to the x power in blue writing above the button, and that is going to come in handy, but not right now. We are going to be using this log button. In the calculator, this log button is actually log base 10. So we're not going to have to write this in. So in the calculator, it's just written as log, except the 10 likes to hide. So that's the first thing that I wanted to go over. So let's take our calculator out, turn it on. We're going to go to y equals, and I am going to, actually I could clear this out. Okay. So we can push the log button, and then once you do that, you see that the parentheses come up, push your X button, remember your X button is right here, and then you close your parentheses. It's important to close those parentheses. Now what I'm going to do is I'm going to zoom, and then I'm just going to go to number 6, which is standard. It brings you to a 10 by 10 grid. And you're going to see that it almost hits the 1 here for that y-axis. We could find that's the minimum of the graph. We could find it, but just for sketching purposes, we're just going to go, above that -1. -1, and we see that it does cross the 1 for the x. So I'm just going to draw it just like that. So it does cross the 1, and it almost touches that -1 for the y. Okay, so let's label that. G of x equals log 10 of x. All right, now that we have that one, now let's go and see what happens when we put in log base 10 of x minus 2 plus 1. So let's go back to our graphing calculator, press the y equals. We now want to add the second graph in, so we're going to press log. We're going to put x minus 2, closing our parentheses, plus 1. Let's press graph and see what happens. Perfect. Okay, so let's look, and now we see that it actually moves up and it moves over. And so it looks like it's almost touching that 2. So what I'm going to do is I'm going to start it here, and then I'm just going to go up a little bit. And I'm going to label it f of x equals log base 10 of x minus 2 plus 1. Doesn't have to be perfect, but you're going to notice that it does move from -1, almost touching -1, to almost touching the 0 here for the y, and it moves to the right about 2 spots. So that's what we're going to describe. We're just going to say that it moves up 1 unit, oh, 1 unit 1, and right 2 units. Now, where do you think we get this 1 and 2 from? I'm hoping that you're realizing that the 1, that's how much we moved up. And this 2, that's how much we moved right. Now, I know it's minus, but this is, if you remember back to our quadratics unit, this minus, we actually go in that opposite direction. So if this was minus, we go right. If it was plus, we would go left. So this is going right 2, up 1, up 1. There we go, and that's where the numbers come from. And notice our parent function does start nicely on this y-axis. All right, next, write down the equation of the asymptote. So remember, the asymptote of f. Remember, the asymptote is where the point where the graph will never touch. It won't ever go there. And so first, we need to find the f for f. So what I'm going to do is, sometimes they give you these letters, match them up. So they want us to look at the f1. So we're going to be looking at f of x equals log base 10 of x minus 2 plus 1. I actually like to take this letter, match it up so we can see which asymptote we're talking about. And so we're actually looking at this one right here. Now, we don't know if it's touching 2. Let's actually go and figure out if it's touching 2 or if it's trying to touch 2. Because remember, that's what the asymptote is. So let's go back, turn this on. And now remember, we're looking at the red one. So we want to find if the red graph, if that minimum is actually at 2. That's the minimum there. It's the lowest point of the graph and it just goes up from there. So let's actually press second trace. And can we find that minimum? Yes. We're going to press number 3. And I need you to notice, it's asking for left bound, but be careful because it's on the blue graph. So if you press the up button, do you see how it now turns to red? That means that we're on the red side of we're on that red graph. So be careful, these colors correspond to which graph you're talking about. We want the red one because we want the F1. So left bound, so we're going to try to get close to that minimum there. Enter, and then right bound, we're going to go a little over on the right side, enter, and it wants you to take a guess. Now let's look. This is 2.21 down here. That's the minimum, 2.21. Does it actually get to 2.0? No. The lowest point is 2.1 comma 0. This is really very close to 0. So is x ever going to get to 2? Nope. So our asymptote is that x is going to always be greater than 2 or 2.0000. It can be 2.1. 2.1, so this point right here is 2.1 comma 0. It can be 2.1 because that is greater than 2, but it's never going to reach it there, and that's what an asymptote is. What point will it never reach? Okay, write down the equation of the asymptote of G. So we go G function. So I'm going to put my G function in so that I know which one I'm talking about. So now we're talking about the blue one. So now we want to see, okay, here's that lowest point. It stops there. It doesn't go past that. So let's go and now calculate the minimum for the blue graph. Now, is it on the blue graph? Do you see this blue? Yes, it's on the blue. So let's go to the left as far as we can get. Enter. Let's go to the right, enter, and press enter for a guess. And we see that minimum. Look here. 0.15. So I'm thinking that our asymptote, it's never going to reach what number? You're right, it's never going to reach 0. So it's never going to reach 0. So x is always going to be greater than 0. It will never reach that 0. 0.15, that's fine. This is 0.15. It's not actually even touching. It's not touching the y-axis, everybody. It looks like it is, but it's not. So that is 0.15 comma 0. Not actually touching that y-axis. Isn't that amazing? Okay, so now I want you to notice for our f graph, look at our 2. Look at our 2. Wow, that's pretty neat, huh? For this one, we could put in plus 0. It doesn't have anything being added or subtracted, so we could put in that plus 0 here. Look at this. And some mathematicians might say, can you use the proper, we could do minus 0 too. That's fine. That's part of the actual function equation. But it is going to be the number that's next to that x. If there's no number there, it's going to be 0. So that's going to help you tell where your asymptote is going to be. All right, now the range and domain and range. So find the domain and range of f. So remember, it's this one right here. Well, we already have the domain. The domain, x has to be greater than 2 because it can't ever be. Now the range, remember the range is the y value, the f of x value. So we see for our f, this is the one that we're on here. What do you know about the range? Is it going to be any of these negative numbers down here? Does it go below? No, it doesn't. So this range is going to be y is greater than 0 because it's not going to go below. So y is greater than 0. All right, how about the g function? So here we have our g function, and we have our G function here. So you're right, the domain x is going to be greater than 0. How about our range? Now, our range, it does go to that negative, it does go in the negative y values right here. Let's just see. Remember, this is my blue line. I'm on blue. Here's my lowest number, my minimum. That's the bottom, very bottom. And so I noticed that it's y equals negative 0.8195. So let's say that my range is going to be y has to be greater than, what would you say, like negative 0.8? Because it's not going to go below. It's going to go negative 0.81, but we can approximate there. So that's how you go and find your domain and range, your asymptotes, and to describe how one graph changes from another. Hope it helped.